starting away for a month. It's like it's beginning of the semester, but already at the end. Almost. Okay, let me share my screen and I will record this lesson. Okay. So today, did you guys watch the video that I shared with you with the examples? I shared that video with you for the examples for section 1. Okay, so if you haven't watched it yet, please watch it. I think it's gonna help you to solve some problems. Okay, make sure you watch it. It's less than 5 minutes, I guess. Okay, so today we're gonna move on to sections 4. This is yeah, we are not doing all of the sections in this chapter. We finished the section 3 last time. We are not doing section 2. So we're moving on to variation, section 4. And today, I'm gonna share this story of Gulliver's Travels. You know the stories of this, right? Okay, maybe it's been a long time, so you might have forgotten. I will show you just a little bit. Okay, so we got the idea, right? Okay, we don't have time to watch all of these videos, but still, Gulliver went to Little Christian's village, right? And on your paper here, um, we have a small task to do. So let's see. Gulliver was shipwrecked on this island in a little pit where the people were only 6 inches tall. When the Lilliputians decided to make a shirt for Gulliver, a Lilliputian tailor stated that he could determine Gulliver's measurement by simply measuring the distance around his thumb. He said, twice around the thumb equals once around the wrist. Twice around the wrist is once around the neck. Twice around the neck is once around the waist. It sounds like thumb, isn't it? So, using this information, can we figure out his measurement of wrist, neck, and waist if we know his thumb size? Because he's humongous for the Lilliputians, right? It's not easy for them to measure his neck, his wrist, and his waist. So instead, what they're gonna do is they're gonna measure only his thumb and figure out his wrist size, neck size, and waist size. This is another integration part we can do, integrating literature with mathematics. It's just like we did with social studies last time, right? Okay, so this is one way that you can think about doing an activity with your students too. So this is showing the direct variation because if his thumb size goes up, his wrist size goes up as well with the same constant, constantly it goes up, right? And if his thumb goes up, size goes up, it's his neck size goes up, and waist size goes up as well. So can you use the information from the description here and fill up the table? So if his thumb size is 0 inches, of course wrist is 0, neck size is also 0, waist is also 0, right? How about if his thumb size is 1 inch? What could be his wrist size? It's twice of that. How about the neck size?
4.
How did you get that?
It's 2 times around the room.
Yeah, that's what it says, right? The neck size is twice as big as the wrist. So it's going to be twice of the wrist, which is 4. How about the waist? 8, because the waist is twice as big as the neck. You can fill up all of this table, right? And I believe Jane has been finished. More of you work on that. Okay, once you are done, I want also you to figure out the relationship between the thumb size and the neck size, as well as thumb size and the waist size. So we know the relationship between thumb size and the wrist size. Wrist is twice as the thumb, so we can say that W is equal to 2T, right? W is equal to 2T because W, wrist is twice of the thumb size, 2T. How about the neck size? Can we write this as in terms of the thumb size? So I'm going to ask you to figure out what could be N neck size in terms of T. What do you find? What did you find? N is equal to 4T, 4 times as big as the thumb. How about the waist, X? X is 8T, 8 times of the thumb size, right? So no matter what the thumb size is, we can figure out the wrist size, neck size, and waist size. because we found the equation for each of these, right? So something like this, we call that as the direct variation. There's a reason why. How about you guys? I didn't give you the grid paper, did I? Let me see if I have enough grid paper. No, I don't have grid paper. Oh, actually, on the other side, on the back of your paper, there's a grid paper, right? Okay, so using this information, can you draw a graph in between thumb and the wrist, thumb and the neck, thumb and the waist? So you want to draw three different graphs. If you have three different colors, you can do that. If you don't have three different colors, you can just use different, dotted lines, thickness, or whatever. Okay, to distinguish one from the other. So I want you to draw three different graphs. One with the width in terms of the thumb, one for the neck size in terms of the thumb, and the last one, waist in terms of the thumb as well. You got it? So I believe you have similar to mine, right? So we have 0, 0, 1, 2. So the red one for me is the relationship between the thumb. So my x-axis here, horizontal axis is the thumb, and my y value here is either wrist or neck or waist. So the red one, this one shows the relationship between thumb and the wrist, right? So when When the thumb is 0, wrist size is 0. When the thumb is 1 inch, the wrist is 2, etc., etc. Right? And you can see the green should be what? Relationship between neck and the thumb and the neck. And the purple, the blue one, should be between the thumb and the waist. You can see that, right? And you can also connect these the dots with what? A straight line, right? Do you see that? You can draw the line there, you can draw the line there, you can draw the line there too. So here at the 0, for my graph, it shows only the red color, but actually green color is there too, and purple is also there too, right? Because it works for all of those three ones. So by examining this, I want you guys to think about what you have noticed from this. Okay, so this is actually direct variation. This is direct variation, this is direct variation, and that's also direct variation. Tell me anything you observe from this activity. What do you observe from this graph especially? What do you observe? Tell me anything. What do you observe? All of this graph, if I draw a straight line there and there and there, they passes through what? 0, 0. Yeah, they all of these graphs, all of these three graphs, they pass it through the origin 0, 0. So in direct variation, they have to go through 0, 0. Okay. 2. What other things do you notice? We already have talked about that. There's a straight line, right? You can draw a straight line. It's not a curve. You see that? It's a straight line. You can see the straight line. And they increase with a certain amount, but it's a fixed rate, right? So this increases, the red one increases by 2 every time. For green, it increases by 4 each time. And the purple one, it increases by 8 each time. So there's a fixed rate, fixed constant, right? Okay, so those are the things that you can figure out from this graph. For this graph here, between thumb and the wrist, I drew. It doesn't look like a straight line because this ordered pair is given on the left hand side here and the right hand side here. But if you draw straight line here passing through these dots only, there is a straight line, right? Okay. So when you're examining this, you can see the straight line that goes through the origin 0, 0. Okay. So we have found all the points lie on a line, straight line, right? And this line passes through the origin 0, 0. And there's an equation. What kind of equation is here for this specific relationship between thumb and the wrist? Wrist is always twice of the thumb, so W is equal to 2T. So there's a constant number that is multiplied. You see that? Okay, knowing that, we can find what the variation could be. So here, direct variation describes a simple relationship between two variables. For ours, it was between wrist and the thumb, neck and thumb, waist and thumb. Between two variables, we have direct relationship there. So we can say that y varies directly with x if there is this kind of relationship. Y is equal to kx. The k is a constant, that is the number that we multiply to. For example, between wrist and the thumb, 2 times thumb is always the wrist size. 4 times thumb was always the neck size, and so on and so on. Okay, so here are some questions for you. Can k be negative? Can K be negative? There's yes. Anybody know? No? Anybody think it's yes? Yes. K can be yes. Can K be a fraction number? Yes. K can be any constant with real number. Okay? Good. Can K be like pi? Pi is also a real number. If you keep multiplying pi to any variables, you're gonna have the same relationship there too. So for example, if you are multiplying this circle by another, this circle increasing the sizes within constantly, then there is a constant variable, okay, constant relationship. Okay, so here are some examples of direct variation. You can see that y is equal to 2x, just like we have here. Y is equal to negative 2x. It's also a direct variation. How about this one? Fraction is multiplied. It's also a direct variation. Pi can be multiplied. Negative pi can be multiplied. Okay? Another question for you. How about this one? Is y is equal to 2x plus 1 direct variation? What do you think? Oh, that's confusing, isn't it?
No,
Why not?
because with the plus one, that is where it's going through instead of 0, 0.
There we go, there we go.
So zero.
It's shifted up from the origin. We just said that direct variation has to go through the origin, but it's shifted up. So it doesn't go through 0, 0, but it goes to 0, 1, right? So if you shift the graph from 0, 0, it is not a direct variation anymore, okay? So no, it's not the form of y is equal to kx, okay? So it is not direct variation. You get the idea of a direct variation? Okay, awesome. Okay, so using the table on your worksheet, now can you write an equation? Can you write an equation that describes the relationship between the two variables? Like this. Can you fill up this blank? So I want you to think about the relationship between neck and the thumb. We already did that, right? So we didn't do these. So between neck and the thumb, we know it's gonna be 4 times. Neck size is always 4 times bigger than the thumb. So we know it's gonna be 4t, right? How about wrist and the waist? Wrist and the thumb. Waist and the wrist. I need to think about that too. Okay, so let's take a look at this together. So look at your table and do this together. Neck size is always how many times of the thumb? 4 times of the thumb. So yeah, if the thumb is 0, neck is 0. If thumb size is 1 inch, neck size should be 4 inches, and so on and so on, right? How about between W? What's W? Waist. Between waist and the wrist. Which one's bigger? Waist is bigger or wrist is bigger? Waist is bigger. So we get to know that this number has to be bigger than 1, right? So how many times of the wrist is the waist? 4 times as well, right? So if the waist, if your wrist is 2 inches, your waist was 8 inches, 4 times, right? And if your wrist is 4 inches, 4 times of that is the waist, which was 16 inches. You can get to know. How about T and W? Oh, this is going backwards. Now we are figuring out what's the thumb size when you are given the W wrist size. We know W is 2 times of the thumb. Wrist is 2 times of the thumb. How about the thumb? The thumb is
One half.
half of the wrist, right? Very good. So it's half of the wrist. And this is again still the direct variation, right? How about this one? W, waist, wrist and the waist, wrist and the waist. We have this information here. Waist is 4 times of the wrist. Then wrist should be 1/4 of that. How do we find that? Let's think about this one first. So we know wrist is 2 times of 2 times of the thumb size. To find the thumb size, you can divide both by 2. If you divide both numbers, same number on both sides, the equation doesn't change, right? So we get T is equal to W over 2. We got that. This is same as 1/2 of W, 1/2 of W. So we got this information, right? Using this, we can do the same thing. If we are given x is equal to 4W, how can we find the W in terms of x? You can divide both by 4. So divide both by 4, divide both by 4, and you get W is equal to x over 4, or 1/4 times x. You can find it right away, okay? So W is equal to 1/4 of the waist. So if you are given the waist, you can find the wrist, vice versa. If you are given the thumb, you can find the neck. But if you are given the neck size, then you can also find the thumb size as well. So you can always find the answer for vice versa. Any question for that? Are we good? All right. So let's keep moving on then. Okay. Now let's do some inverse variation. To do inverse variation, I'm going to give you a different sheet of paper. Okay, so you are given 2 rectangles there. In rectangles, with the same number of the blocks, you can form a lot of different sizes of rectangles. But you're gonna use all 36 square blocks, okay? Using all of these 36 square blocks, there are actually 9 different ways of the arrangement. So I'm giving you only 2 ways of the arrangement here on your worksheet. Can you find the other 7 ways? So I can have a height of 4 and base of 9. Then you can do the vice versa, right? You can have height as 9 and base as 4. That could be 1. So think about all the other ways and fill up the chart on your worksheet. Make sure you are using all 36 square blocks. Let's go with the smallest size of the height. What is the smallest size of the height? Just one block. Then the base has to be 36. So the area is 36, right? What can go next? 2. If the height is 2, the base should be 18. 2 times 18 is also 36. How about 3? Can we have 3 inches? 3 height? 3 blocks, then the base should be 12. So the area is still 36. We are using all of that. Then we are given 4 and 9, and 6 and 6. Then we can go the other way around, right? We can go from 9 and 4, which is 36, and we can have 12 and 3, 36. We can have 18 and 2, 36, and 36 and 1. Is this what you have on your table? Everybody? Okay, awesome. So these are the 9 different ways. What do you notice from here? Tell me anything you notice.
As the height goes up, the base goes down.
Oh, when height goes up, you see that? Height goes up, then the base goes down. Oh, so it's not direct variation, but they are inverse, right? They are inverse variation. What other things do you notice? How about area? The area is the same. Oh, it's constant, right? It's not changing. It's always the same. Area is same, right? But height and base, if one goes up, the other one goes down. So they are indirect variation there. Okay, awesome. So let's take a look at the next one that I have here. When the height increases, the base decreases. When the height decreases, then the base should be increasing. Yeah, you can see there is indirect variation. Okay, so h times base, height times base is always 36. Then height is equal to, you can divide both by b, right? H is equal to 36 over b. How about if you divide both by h? You can find what b is. The base is always 36 over h. Can you compare this with the direct variation? There is something similar and there is something different. What do you notice between direct variation and indirect variation? Tell me anything that is similar or different between direct variation and indirect variation.
You still have your constant, but it's divided by instead of.
Oh, so both they have constant, right? Constant and constant. Okay. Anything else? Anything different or anything similar? We just found the similar ones. Both they have constant, right? They have constant rate between direct variation and indirect variation. So we use a K for that. Okay. Anything different? What is the difference between direct variation and indirect variation? For direct variation, if one variable goes up, the other variable also goes up, right? So one goes up, then the other one goes up too. For indirect variation, one variable goes up, then the other one goes down. Right? That's the big difference. So these two are the most important things that you can figure out. So direct variation, we can have y is equal to kx, where k is the constant, right? Indirect variation, how can we find it? It's indirect variation. So k is constant, it's still there, but one goes up and the other one has to go down. So that x goes to the denominator. Okay, that is the indirect variation. So you can use this form for direct variation and indirect variation. Okay? Okay. here, inverse variation. We say that y varies inversely. Inversely, that's how it goes to the x goes to the denominator. Okay. Inversely with the x. If y is expressed as the product of some constant number k and the reciprocal of x, okay, which is 1 over x, then it is inverse variation. So we can write it this way. You can compare this to direct variation, right? Direct variation is y is equal to k times x. The inverse variation, you have x in the denominator. Y is equal to k over x. Okay? This is the same thing. K over x is the same as k times 1 over x. Right? Okay, so we can get to know. And here's one example that you can solve using either direct variation or inverse variation. The loudness L of a stereo speaker measured in decibels varies inversely as the square of the distance d, of the listener from the speaker. So let's think about this, loudness from the distance of the speaker. So if you go closer to the speaker, it goes louder. If you go far away from the speaker, what happens? It gets quieter. So decibel goes down. So distance increases and then decibel goes down. So it is inverse, right? Inverse relationship. So let's use this one to set up an equation. We are given all the information in this example. When you're reading this carefully, you get to know how to set up an equation. So let's see. The loudness of L, loudness is L. So L is, it is measured in decibels, varies. So L varies. You can say that L equals inversely. So whatever that variable, changing variable goes in the denominator, right? Inversely as the square of the distance. So square of the distance goes to the new denominator. What is the constant? We need to find it out. Okay, this is the equation. And now let's use the information to find what K is. If the loudness is 20 decibels, the loudness is L, that's 20 decibel when the listener is 6 feet from the speaker. So D is 6. You can put 6 square there. Then you can find what K is, the constant is. Okay, so find the constant in that way. So we have 20 is equal to K over 36. How can we find K? We can multiply 36 on both sides. Because it's in the denominator, right? Then we have K is equal to, what's 36 times 20? 720. So K is 720. Now we can plug this back in to our original equation, because we have an equation, but we have to find out what K is, the constant is, right? So plug it back in, then we have equation L, loudness in decibel, is 720 over distance squared. So this is the formula we're gonna use. Okay, and that shows the relationship. Now, it says just determine the equation that expresses relationship. So this is the equation that expresses relationship between the distance and the loudness. Okay, let's look at the next question. Next question is not the example. So I have joint variation. Joint, what does joint mean? We're joining things together, right? So, joint variation, one quantity may vary directly as a product of two or more other quantities. So you have direct variation, not only with one variable, but there are different variables too. Okay, so if you have only one direct variation, we have y is equal to kx, right? So you have another variable. So for example, y is equal to k is a constant. Not only x, you can put another variable like z. Okay? The joint variation, you're multiplying another variable to that, where constant is still existing. For example, write the variation and determine the quantity indicated. B varies jointly as f and c. So we know B is equal to K. There's a K constant. We need to figure out what K is, right? K times F and C, F times C. Does it make sense? So we can set up an equation this way. Okay, so how can we find this? Okay, we have D. D is varying, since this is independent. D varies jointly as F and C. F and C. So F and C is, you need to multiply them together. However, there is a constant. This is what you need to figure out, right? To find the correct relationship there. So you are given another information here. Determine D when F is 7, and C is 8, and K is 4. K is given to you. Now you can just find the D. D is 4 times 7 times 8, which is
224.
124. 24? Thank you. 124. So this is joint variation. Okay, very simple. How about okay. So I have a summary of a variation of equations. Direct variation, y is equal to kx. K is the constant. Inverse, y is equal to k over x, where k is also constant. Joint variation is direct variation with more than one variable. So k times x times z. Right? And here I have one more, combined variation. Combined variation, you can combine everything together. You can combine, direct variation with an inverse variation, or inverse with joint variation. You can combine all of those kind of variations. Okay, so let's look at these examples. The load L that a horizontal beam can safely support varies jointly. With the product of two variables as the width W and the square of the depth D, and inversely as the length. So that L goes to the denominator, right? But there's a constant K, don't forget that. So can you set up an equation for this specific example? The load L that a horizontal beam can safely support varies jointly as the width and the square of the depth, and inversely as the length.
Yeah.
Did you get it? Okay, so how did you do that? The load L varies is equal to jointly as the width W and the square of the depth D. The square of D. Did you multiply them together? So this is jointly, right? The joint variation. So there should be constant K. And it's inversely, this load is inversely related to the length L. So L can be expressed with KWD squared over L. You got that? Any question for this one? You good? All right. How about the next question? The owners of Henrietta Hot determined their weekly sales of hot dogs as sales of hot dogs is as very directly with their advertising budget A, and it's related to inversely with their hot dog price P. When their advertising budget is given at $600 and the price of a hot dog is $1.50, they sell 5,600 hot dogs a day. Using this information, you can find what K is, right? So let's set up an equation first. Okay, so hot dog, number of hot dogs S. Okay, number of hot dogs sale is S. S vary directly with their advertising budget A, so KA, right? And it also varies inversely with their hot dog price P. You can set up this equation. You agree? Okay, now we can find K using this information. When their advertising budget is 600, so A is 600. A is 600. And the price of a hot dog is $1.50. So P is $1.50. And then they sold 5,600 hot dogs. Using this information, what can we find? We can find K, right? So if we multiply 150 on both sides, 150 on both sides, this will be gone, and we can have K times 600, so we can divide both by 600, then we can find what K is. The K can be written as 5,600 times $1.50 over 600, right? So I'm gonna divide both by 100, make it easier. Okay, and it's not reducible. Just by 2. Okay, let's do that. Divide 3 divided by 2, 28 times 150. 150 can be divisible by 3, and you get 50 cents, right? So $28 times 20, half of a dollar is 14. I mean, what is it? $14. I mean 14. Yeah, so K is 14. So our constant is K, which is 14. So S is 14 times A divided by P, right? Using this, you can determine the expected sales if the advertising budget is 800. The advertising budget is 800. And the price is $1.75. You can just calculate this to estimate, the sales, number of sales. Okay, so we will stop here. That's the variation. And keep an eye on the homework, email about the homework, okay? And I will finish it here. We are already 1 minute over. So have a great weekend, guys, and keep an eye on the email.